Angela Godwin with Water World Magazine, coming to you from the show floor at WEFTEC 2012 in New Orleans. Talking with us today is Dave Eifert of Phoenix Contact. Dave, thank you so much for being with us.
Thank you for interviewing us.
Well, why don't you tell us a little bit about what you're highlighting here at the show this year?
Well, the highlight is generally making simple solutions for the water industry, as has to do with automation and controls. And so one of the things that we have is this product right here. It's an SMS-based RTU for the cell network to get simple alarm information from remote sites that are established back to a central SCADA host, and doing that using the cellular network that's widely available.
And what's the advantage of that?
A lot of different customers don't have the ability to provide funds to get an entire radio system, or maybe they're widely dispersed geographically and they can't get a good connection on a traditional radio system. So this allows them to leverage the cell towers to get simple alarm messages from the sites very cheaply and inexpensively back to the central station.
So Dave, I understand one of the trends in the industry is that leased lines are going away. How does your product fit in with that?
It's very true. Most of our customers are struggling with that right now. So lease lines have been established for 30 or 40 years. The telephone companies put them in. They're not interested in that business really that much anymore for the most part. So now we're seeing a trend where the prices are really going up on lease lines and the quality is going down. So this then abandons those, but maintains connectivity with these remote assets, but now using the cell network, which the companies are very interested in keeping up and going and getting into that business very heavily with machine-to-machine communications. Yes, and I have another RTU that I'd like to show you next that offers a lot more flexibility and more capability.
Great, let's go take a look.
Whereas the last RTU is cellular-based and fairly simplistic, this one is much more capable and much more scalable and offers a number of different communications options. So you could go cellular from this if there's no existing infrastructure, but there are other means to communicate with it. And then once you're into the RTU itself, there's a lot of processor power and functionality, as well as ways of maintaining uptime and reliability that are not quite as present in the last product. So this one we're showing operator display in the front of it, which is an option. It's not essential. But what this is actually doing is there's no HMI software on this display itself. It's actually pulling up web pages that are on the controller inside.
Wow.
And so what that means is we can look at it locally here, but we can look at these same screens from any internet-connected PC or tablet that's anywhere on a network. So it's very, very nice to be able to have that visibility into the process from wherever you are, as long as you've got an internet connection.
Sure.
All right, shall we have a look inside?
Sure.
So the controller's down here at the bottom, and that's where all the logic is occurring for the process. And the communications to it, to a radio of your choice. So this happens to be a high-powered Ethernet radio. One of the other features here is that the power supply is actually working in tandem with a UPS. So if you were to lose power to the station for whatever reason, you're going to be able to keep visibility in your process and keep your logic running indefinitely until the battery would run out. But typically it's short duration, so it usually has you protected through the entire duration of an outage.
So Dave, you guys also have a product for cybersecurity.
That's correct. I'd be delighted to show that to you.
Let's go take a look.
Thanks. All right, what I'd like to show you here is a process that's running fine right now, but we're going to intentionally create a broadcast storm, a denial of service attack, using this laptop. It's going to stop the PLC from functioning properly. The lights will go out and the bubbles will stop. That's a bad thing, simulating a loss in your process. After that, we'll install our MGuard product into the mix, and it'll act as a stateful firewall and protect the PLC and your process. So right now I'm going to simulate that attack. Only took a second to knock out your process. Okay, what I'd like to show you now is we've interjected our MGuard product, which is functioning as a stateful firewall, so that now this attacking PC must go through the firewall before it can get to the PLC. So I'm going to initiate the same attack we did before, which had devastating consequences. Now it should have no effect on the process whatsoever. Okay, we're sending all the harmful packets again, but as you can see, everything's functioning normally, as it should.
Now, Dave, I know that for Phoenix Contact, reliability and uptime are really important. So what kind of solutions do you have that address those?
Well, absolutely. One illustration of that was this for cyber reliability, but over on the board in back of us, we have some other power solutions for reliability and uptime.
Great, let's go take a look.
Sure. Yeah, what I'd like to show you now is some more reliability and uptime type solutions. These have to do more with power than cyber. Over here we have some transient voltage surge suppression for signals, and there's a bus structure behind here that if any one of these modules goes bad, the head station will know that and report back to the SCADA system. As an example, you can see everything's green lights. As soon as I remove one of these modules representing a problem, the head station realizes that and not only visually indicates it locally, but will close a contact that'll go back to your central SCADA host saying, hey, go out to that station, there's something wrong with that station. So that's one example. And in regards to power, uptime, reliability, this down here is illustrating a power supply. We've done it back up with an O-ring module to share the load. Beyond that, there's a UPS and a battery. And the UPS is intelligent, and it's called the UPS Quint IQ, and it's able to communicate back over this cable either via USB or serially or via Ethernet. And now it's able to communicate a number of different parameters back to some software, which could be back at your SCADA host. Things such as the percent charge on the battery, the expected lifetime of the battery that we have left, and the state of function of the battery, which is how healthy that battery is. So now somebody back at headquarters can proactively know, hey, everything's running fine today, but it says here in my software that the battery's got 3 months life left on it. Let me schedule some maintenance to get that changed out before that time frame, proactively.
Excellent, great. Well, Dave, thank you so much for the overview of all the stuff you guys have here on display. We hope you have a great show.
We have so far. Thank you very much.
Great, thank you so much. And for Water World Magazine, I'm Angela Godwin.